Okay, there we go. Maybe I need to mute myself. There we are. Got it. All right. Hello. How's everybody doing today? Very good, Gianna. I hope you're doing pretty well. Okay, we'll wait for a couple more minutes for people to come in. I know it was a little late getting in here. Then we'll get started. We'll get stuff done. Hopefully we get stuff done. Yep. Alright. Should be good. What sections we'll be covering today? We'll be covering multiplication of fractions. Okay, so that's going to be 2.5. We'll be covering the rest of that today. 2.6 as well, which is going to be applications on multiplying fractions. And 2.7, which is division. So that's what we're doing here today. Lots of stuff. Try to keep it as basic and easy as possible. Okay, we'll start in just one more minute, and other people can start coming in here. So okay. All right, let's go ahead. Let's get started here. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, um, we're going to continue where we left off last time. Last time, we left off at talking about in section 2.5, talking about multiplication of fractions. Now, we did a few examples here from last time in regards to multiplication of fractions, but obviously we want to continue moving forward here with a few more examples so we can see exactly how we can, simplify before we multiply. Remember, that's really what we want to do in these sections here as best as we can. So let's start off with something nice and easy here. We'll go with, again, 5 6 plus times 9 tenths. I think that's a very good problem. So let's go ahead and do that. All right. So 5 6 times 9 tenths. Okay. So that's our problem here. Okay, I guess I should probably write it on the thing here instead. Okay. All right. So remember, we want to simplify before we multiply. So we need to find a factor that's in common that we can divide out on both the numerator and denominator. So both the top and bottom here. Okay. So let's take a look here. What two numbers are in common that have a common factor according to this problem here? What two numbers can you see here that have a common factor? Again, a number that's in common between both of them. So see, we have 5 and 9 on the top, we have 6 and 10 here on the bottom. Okay, with multiplication, we would normally just multiply straight across. But again, we do not want to multiply these numbers because they're going to get pretty big. So my point of my question is that what can I divide? What two numbers have something in common on the top and the bottom, the numerator and denominator? All right, very good. 5 and 10 and 6 and 9. All right, let's look at 5 and 10. What can we divide by? What's in common between 5 and 10? All right, 5. That's correct. So we're going to divide by 5 here, and we'll divide this 10 by 5 as well. If we do that, we have 5 divided by 5, which becomes 1, and 10 divided by 5, which becomes 2. All right, fair enough. How about 9 and 6? What's in common between 9 and 6? What factor is in common between 9 and 6, i.e. what number divides both 9 and 6? 3. That's right. So we're going to divide 9 by 3, and we'll divide 6 by 3. So 9 divided by 3 is 3, and 6 divided by 3 becomes 2. All right, good stuff. So right now now at the end of the day, we have 1 times 3 on the top, and 2 times 2 here on the bottom. Now we've reduced it down to its most basic form because we don't have anything else in common. So now we have 3, 1 times 3 is 3, 2 times 2 is 4. So 3/4 is your final answer for this problem. Okay. And that's it for that problem. Are there any questions about that? Just move on here to the next one probably. But we're going to try another problem anyway. So let's give this next one a try here. 7 tenths times 20 over 21. So let's give that a go. So we're able to cross multiply in this section. We're not cross multiplying. No, cross multiplication is completely different. In this particular section, we're talking about reducing before we multiply straight across. Remember that the rule here for multiplication of fractions is going to be, again, if you have something like this, will be AC over BD. Again, if you're just multiplying A times C and B times D. Okay, so you're multiplying straight across as a general rule, but to make the problems easier, I don't want to have to figure out, like in this problem here, if I multiplied straight across, I would get 140 over 210. And in reality, 140 over 210 is two numbers that are way too large that I really want to be dealing with. Instead, we want to reduce it down before we go ahead, and to do that we need to find a common factor between, say, two numbers. Again, one has to be in the numerator and one has to be in the denominator. So that's why we're dividing out, say, by 3, because 9 and 6 has a common factor of 3. 5 and 10 has a common factor of 5 that we can divide out. That's essentially what we're doing here in this section. So if I were to look at this particular example, 7/10 times 20 over 21, what would be two numbers that have something in common with each other? So one you have to pick from the numerator and one you have to pick from the denominator. Two numbers that have the same factor. Ten and 20 and 7 and 21. Okay, let's look at 10 and 20 first. So we have 20 on the top, we have 10 on the bottom. All right, what's something that we can divide out by, aka pare down? 7/21 can divide by 7. That part is definitely true. Totally agree. Let's divide those by 7. How about, all right, 20 and 10 can be divided by 10. Yeah. Yeah, actually you could divide, Hannah, you could divide by 2, and then you'll find out that so I'll show this off here, because that answer, like 10 is the max number here, but let me show off what happens when you do it with 2. Even with 5, that's fine. They're both okay. So let's say you start with 2 here, which is perfectly cool. Then you get 10 divided by 2, which is 5, and 20 divided by 2, which is 10. But then you notice you have a 10 and a 5, all right? That has a in common. So you could choose 5 here, all right, and you'll still end up right where you need to be. So you get 5 divided by 5, which is 1, and 10 divided by 5, which is 2. Okay, so both answers that you stated there are perfectly correct. Okay, there's no difference in how we kind of approach that. So if you need to take 2 steps to reduce down, then take 2 steps. If it takes 1, okay, it takes 1. All right. All right. So here we get 1 times 2 over 1 times 3, and so here we get straight up 2/3. Okay. Okay. Yeah, that's perfectly fine. Yeah, you just have to do it in 2 steps if that's the way you want to kind of think about it. If that's the way you kind of want to think about it, then you just reduce it by 2 steps there as opposed to 1. So that's kind of the important part here, is like you don't have to like get the whole chunk right away if you don't see it right away. You could just go slow and just take it one piece at a time too. Nothing wrong with that whatsoever. Let's take a look here at another problem. 2/3, 8/15, and 3/4. All right. Let's do it. Okay. So here we're multiplying 3 fractions to each other. Now again, all we need to do is find one number on the numerator, one number on the top, and one number on the denominator, okay? And again, we just want to find a common factor between both of them, okay? So one number on the top, one number on the bottom. What do we got? What two numbers? One on the top, one on the bottom, one in the numerator, one in the denominator. What do we have in common here? Several choices here. Let's start with 2. Let's start with 2. Let's just go down the line here. Does 2 have anything in common with a number in the denominator? Does 2 have something in common with 3? No. Does 2 have something in common with 15? No, because 15 is an odd number. Does 2 have something in common with 4? Yes. Okay, it certainly does. They're both even numbers. So we could take 2 and 4, and we can divide by, in this case, 2. All right, so far we have 2, and this becomes 1. Okay, let's go down the line now. We have our next number here on the numerator, 8. Does 8 and 3 have something in common? Nope. Does 8 and 15 have something in common? Definitely not. Does 8 and 2 have something in common? Yes or no? Okay, so 8 and 2 have something in common, and that is indeed 2. So let's divide by 2 here. So we get 1 here. I'm going to divide by 2 here. And so here we get 4. Okay, now let's look at 3, our last number here. All right, 3. Does 3 have anything in common with 3? Well, of course it does. 3 and 3, well, that's just kind of goes together. So we're going to divide by 3 on both the numerator and denominator. So 3 divided by 3 is 1. Now we have no more numbers that are having stuff in common. So let's take a look at what we have. We have 1 times 4 times 1 on the numerator. And in the denominator, 1 times 15 times 1. So our final answer here, after paring everything down, is 4 over 15. Okay. Any questions about that? Could you do 15 and 3? Yes. So you could divide this by 3 and 15 divided by 3. However, then you would leave this first 3 alone. So it just goes in a pair, okay? So if it was this 3, it would have to go with this 15, but then this one here would still be 3. Okay, so yes, you could technically do that. That's correct, Hannah. But remember that you only go with one number on the top and one number on the bottom. So one in the numerator and one in the denominator. Leave everything else alone. Does anybody else? So there is a number left over? There can be, yes. There can be numbers left over, absolutely. You only can divide out by however many times it goes into each number. So it's not always the case where it's always going to equal 1. There's going to be cases where you do have numbers just left over. That's how we get 4/15 here. Right? It's like we got the 4 left over here, you know. That just happened to be part of the circumstance, that's all. Any other questions? Again, type no in the chat if you have no questions, or type out a question if you do. No questions? All right. Well, let's go ahead and move forward then. Okay. So let's have you guys, I want you to give one problem a try here. All right. So we're going to take a minute or so. So I want you to try letter D here. All right. So 18 over 17 times 1 over 36 times 2 over 3. I want you to give that problem a try here. So I'm going to give you a minute or two, okay? And then we'll come back and do this problem here together. So let's have you practice this problem here now that you've seen what we need to do. And once you got an answer, go ahead and post that in the chat. About another minute. You go 1 over 51. Okay. So I got 1 over 51. All right. Anyone else? This problem's a little tough, so that's okay if you didn't like totally get it. Okay. Let's take a look at this problem here, and we'll see what we get. So, okay. Okay, so let's see what we're working with here. Alright, so we have, again, 18 over 17 times 1 over 36 times, let me reference back to that, 2/3. Okay, now there's a couple ways you can handle this problem here. First things first here, we can divide actually 18 and 36. 18 and 36 actually go in together 18. So you could actually divide by 18 here. If you didn't see that, you could have tried 9 or 2, and you could have kept going, just depending on what you wanted to do. So this 18 becomes 1, this 36 divided by 18 becomes 2, and we have 2 and 2 here, divide by 2, and divide by 2, so this becomes 1, this also becomes 1. So you have 1 times 1 times 1 over 17 times 1 times 3, which equals 1 over 51, which is correct. All right, very good. Now, if you didn't get this right away, that's okay. You know, we're here to cover those bases here, all right? That's important. So, again, just making sure, you know, I'm not expecting to get something like that right away. It may take you more time, but you get the general gist about how we go ahead and we get that. Can you show how to divide by 2? Yes, of course. So if I went ahead and did that, then I would take 18, I would divide this by 2. So here I would get 9, and here I would get 18. And I could say, oh, I could divide both by 9, or I could divide both by 3. Let's say 3, for example. I can take it in small steps. 18 divided by 3 is 6, 9 divided by 3 is 3. And now I can divide both by 3 here. So here's where I get the 2 and the 1 here. And then I can proceed with the rest of the problem just as normal. So if you want to take it in like small steps, you certainly can do that. That's perfectly fine. So you can see that I just took it one step at a time. And then I could just do this 2 divided by 2 here. So there's nothing in common we could divide by then. Yes, you could just leave it. Yeah, you just leave it alone. That's right. That's right, Alyssa. So if there's nothing in common between the numerator, if there's nothing in common between that number on the numerator and a number in the denominator, you leave it alone, you move on to the next one. Any other questions? Okay. All right. Next. All right. Next is multiplying by whole numbers, which is actually rather straightforward. Multiplying by whole numbers isn't as hard as it may seem to be. So let's talk about that here a little bit. It's not too bad at all. Oh, hang on a second here. If there's a 2 divided by 2, what is the 2 corresponding with the denominator? Do you have to divide it by 2 with the... Yeah, so you have to, so if this is a 2, so basically put, if there's a 2 up here, so this 2, all right, and then this one, get the brush here. So yeah, this one and this one, you're both dividing both of them by 2. So yeah, as long as they have a number in common, then that you're both dividing both this one by 2 and you're dividing this one by 2. So what you do on the top is what you do on the bottom. You always have to divide by that same number, so long as it's in common, because then you'll get a nice number that will be reduced. So this will become 1 and this will become 1. So I just circled that about what it would correspond with there. So hopefully I hope that answers that question. Does that make sense? Is it 1 over 6? Are you talking about this previous problem where we got 1 over 51? Like this? So the answer was 1 over 51. Because we had 17 times 1 times 3. So we never reduced the 17 part here. This 17 stayed the same. Let's try another one, okay? And let's take a look at another one, and let's see if we can clear up any of the issues there. That's okay, because the next one here will be with whole numbers. So let's say we're taking 8 times 3/4, all right, just as an example. All right, so let's talk about the key here. Okay. So let's do 8 times 3/4. Now, there is a trick to this, very simply, all right? So let's go ahead and write this one down. Okay, so let's take a note here. All whole numbers can be rewritten as the following. So if you have a whole number, and let's say it's like 5, okay, let's take 5 for example. 5 can be rewritten as a fraction as 5 over 1. Okay, so any number whole number a can be rewritten as a over 1. Okay. All right, so that's pretty much how that's going to kind of go here in this circumstance. So if we look at this here, I'm going to rewrite this this particular one. I'm going to rewrite it as 8 over 1 times 3 over 4. Okay, and then we repeat the same actions that we did in the previous problem. So we want to take a look and see if we have any numbers in common between the top and the bottom to pare it down. Okay, what can we divide by? What two numbers have something in common that we can divide a number by? Eight and 4. Okay, good. All right, so 8 and 4 is correct. Right? It has to be, again, we have to pick one number on the top and one number on the bottom. All right, so it's going to be a pair of numbers. All right, just understand that it's always a pair of numbers. Can you multiply the bottom and add 3? Can you multiply the bottom and add 3? Wait, I don't understand why you would add 3. Um, I'm not sure why you would do that. You have 1 times 4 here, but I'm not sure what that YouTube video told you to do, but I'm just trying to try the most consistent method here. So all right, so we're going to divide by 4 here for both of these, okay? So we get 8 divided by 4, which is 2 over 1, times 3 over 1. And so here we got 2 times 3, and so 2 times 3 is going to be 6. 6 over 1, which is 6. Okay, so that's how we got 6 there. No problemo. All right. Questions about that so far? Hopefully that isn't too bad. We'll go to the next one. All right. Oh, that one can be done later, I guess. All right. Go to the next example here. All right. So they also do talk about area of a rectangle in this section. Just kind of an application. We're going to do a few more applications in the next section anyway. But if you want to know again the area of a rectangle, you probably have known this for a while, so it shouldn't be anything brand new. But why? All right. I would put that. I don't understand. All right. So the area of a rectangle here, the area is equal to length times width. All right, so whatever the length and the width are going to be of that rectangle, that's essentially how we're going to find the area of said rectangle. Again, not too hard if you want to kind of put it together. Let's go ahead and take a look here though at an example or so. Okay, this time though, maybe not with whole numbers, but maybe with fractions. Okay, let's look at letter B. Find the area of this rectangular truck running board. All right, so here are the dimensions listed on the page. So we have the length here being 7/10 and the width here being 5/14. Okay, they're both in yards here in this case. Okay, so what should we do here to find the area of this rectangle? Okay, multiply what? What are we multiplying here? Okay, multiply the fractions. All right, so why don't you tell me how could I multiply these fractions? I have 7/10 and 5/14, which is true. That's the length times the width. Okay, can we reduce these fractions down? Can we pare it down, essentially? What pair of numbers have something in common? What pair of numbers that we can put together we can reduce down here? 5 and 10 and 7 and 14. Good. So let's go with 5 and 10 and 7 and 14. Good. So I'll put 5 in a block and I'll put 10 in a block. And we'll circle 7 and we'll circle 14. We'll say these two are together. What can we divide from 5 and 10? We could divide it by 5. Okay, we could divide by 5. Good. So let's divide by 5 here. So 5 divided by 5 is 1, and 10 divided by 5 is 2. Okay. How about 7 and 14? What can we divide by? 7. That's correct, right? So we have 7 here. So we have 7 divided by 7, 1, and 14 divided by 7 is 2. So then putting this together, we get 1 over 1 and 2 over 2. So we get 1 over 4. So this would be a quarter square yard. Okay. And this is how we get our final answer for this problem. Okay. All right, questions about that? Again, type no in the chat if you have no questions, then I can move on. Otherwise, type out your question if you have one. All right. Now there's a few more there. That's okay. All right. Y yard square. Y y yards squared. The reason why it's yards squared is because with the units, you're actually effectively taking yards times yards. So that actually turns into square yards. So if you know, like for example, in a house, we say it's square feet, right? We say, okay, the house is 3,000 square foot house or whatever. That's the reason why we call it square feet, is because we take feet times feet in terms of the dimension of the room. So the same thing applies for this question here. When we take yard times yards, we get square yards here as well. So, or again, yards squared, they mean the same exact thing. So that's effectively how you come up. Yeah. So that's effectively how you come up with that. All right. Let's go ahead and take a look here at the next section, which is section 2.6, which is applications of multiplication. Now, we saw one application just now with the area of a rectangle, but there are definitely more applications of multiplication outside of just that. So let's take a good look here at these problems. Okay, again, these are all going to be word problems. So we're going to talk about some of the indicator words that we want to be looking at here, i.e. the keywords there in the word problem, in order for us to figure out how to set up that problem. And then after that, we'll go ahead and do the calculation out. So let's take a good look here at several problems here, and we'll talk about the big keywords here in this particular case. So let's go to our Word document here. Okay. Okay, so keywords for multiplication. It's going to come down to, again, you will see product, multiply, all right? You'll see times, okay? We all know that these are keywords for multiplication, but the one that we're going to focus on here is going to be a little different than maybe what you're used to. Let's take a look at this first example here, and we'll see exactly what our keyword is going to be in this problem. Let's look at this first one here. So Lois gives 1/10 of her income to her church. 1 month, she earned $2,980. How much did she give to her church that month? Okay, so there's a lot of words in there, but there is only one of those words that actually matter and that actually indicate to us that we're going to use multiplication in this problem. Let's see what we get. So exactly what word is that? Well, surprisingly enough, that word is the word of. All right, so of all the words in this particular word problem, of is going to be the most important word in this word problem. The reason why is that that is definitely a keyword for multiplication. So when it says here, Lois gives 1/10 of her income to the church. So 1/10 times her income. All right. So let me go back here. So we get 1/10 of her income. So that's going to be 1/10, and then of will be multiply, and then her income, whatever that is. All right. So all we're going to do here, in this case, let's take a look here at this particular problem. All right. So she gives 1/10 of her income to the church. 1 month she earned $2,980. Okay. So in this particular case, we're going to take 1/10 times 2980. Okay. Now you could do this on, for this one here, if you get pretty large numbers, you could do this on the calculator, that's fine. So you could just do that as straight up a calculation there. 1/10 times 2980. And can anybody tell me what we get here? What's our answer for this? Did I get your email? 298 is correct. Was this about the test there, Jonathan? Did you just send the email? Sorry, I. Oh, okay, okay, okay. That was regarding the test, right, Jonathan? Because if it was for the test there, then I did get your email. Yeah. I don't need to see the work for the homework. I need to see the work for the test. I just want to see work for the test, not the homework. The homework you could do on your own. Oh, you sent both. So, all right, really quick here. Is part 1 the test or part 2 the test? Just to be crystal clear. Just let me know. Because you gave me 2 parts of the homework and the test for that. Okay. Well, we'll take a look here anyway. No worries. All right. Let's look at the next one here. So let's try this one here. So Eric and Sabrina are saving 3/8 of their income for the down payment of their first home. If they have a combined annual income of $81,576, how much can they save in a year? Oh, okay, I see what you did there. Okay, never mind, Jonathan. I got confused. Okay, that's fair. All right, you don't like for future reference, Jonathan. You don't have to send me the homework work. You could just send me the test work over D2L. All right. Can anybody tell me how would I set up this problem? How would I set up this problem here? What should I do? All right, that's correct. Very nice. All right, so let's do this out here. So 3/8 times 81,576. All right. Again, I'm not expecting you to like know what this reduced down to by hand, but you can use your calculator for this. Does anybody have an answer for me here? 30,591. Okay. All right, good. Yes, that is correct. I extended the due date for the test out to the 27th. That's correct. So if I make sure you get it done by then, okay? I was asked and I extended it out, but that's as far as I'm going to extend it out. So make sure you get it done. Same goes for the homework too. All right. Let's move on here. Okay. Let's look at this second example here. Of the 39 students in Miss Martin's high school econ class, 2/3 plan to go to college. How many plan to go to college? All right. So it says of the 39 students. So the key thing is, as we talked about, of here is going to be the big word. Of the 39 students, 2/3 of them plan to go to college. So how do we set this problem up? How should we set this problem up? 2/3 times 39. Spot on. So far, so good. All right. And what do we get here? What's our answer for this? 2/3 times 39? 26 is correct. Good. So far, so good. All right. Okay. Okay, so this last one here is going to be the toughest one here. So this is the one I want to focus on here in this section. So let's look at this third example here. And we need to read it very carefully in order to kind of get the interpretation down. All right. In her will, a woman divides her estate into 6 equal parts. 5 of the 6 parts are given to relatives. Of the 6th part, 1/3 goes to the Salvation Army. What fraction of her total estate goes to the Salvation Army? Okay, so let's talk about what the important part here is, okay? What exactly is the important part? We know that the first 5 parts are given to relatives, so you're so far so good. Now let's take a look at this first sentence here. It says, of the 6th part. What does of the 6th part mean if we were to write it out using numbers and operators? What would be of the 6th part? What does that mean? Well, let's put it down one at a time here. What does of mean again? Okay, good, good. So 1/6 means the 6th part. All right. And what does of mean? Multiply. And what should we multiply by? What should we multiply by? 1/3. Okay, so take a look here, all right? If we read this carefully here, 1/3 is correct. So of the 6th part, 1/3 of that, so 1/3 of the 6th part goes to the Salvation Army. Okay, so 5 doesn't have anything to do with this problem. 5 just establishes that 5/6 of the estate was given to some random relatives. But the more important part here is this going to be this 1/3 that we have here. So that's the more important part because that reflects the part of the 6th in that case. So in this case here we get 1/18. So 1/18 would be our answer for that. Okay. Okay. Now, I want you to try this problem here. So let's try this problem here. So give this problem a try. We'll take about a couple minutes to do this. So at our college, a third of the students speak a foreign language. Of those speaking a foreign language, 3/4 speak Spanish. What fraction of the students speak Spanish? So let's take a minute or two and do this problem. And once you have an answer, go ahead and type that out in the chat. Okay. Don't forget, Hannah, you got to reduce that down. Don't forget 3/12 does reduce there, Hannah. Okay. All right. I think hopefully that's enough time. All right. So let's take a look at this one here together. All right. So it says a third of the students speak a foreign language. All right. So 1/3 of, and of those, 3/4 speak Spanish. So it'd be 3/4. Again, you could divide the numerator and denominator here by 3. So you get 1 times 1 over 1 times 4, which equals 1/4. All right, and that's our final answer will be a fourth. Any questions about that? Any questions at all so far? Again, please type no in the chat or just ask me a question. Again, it's kind of important that I know if I need to move on or not. Okay. Okay. All right, let's take a look here at this next one. Sure. All right, so this next one here is using a circle graph. So let's take a look here at a couple of these problems here. So it says, what fraction of the children buy food from a vending machine? Well, as you can see here, the fraction would be 1/5 according to the circle chart here. What number of children buy food from a vending machine? This one here, again, this has this little bubble here. They took 2,500 children. as part of the survey, and we want to multiply that by 1/5. If you go ahead and do that here real fast, it's pretty easy here. So 1/5 times 2,500 equals 500. So 500 kids buy food from the vending machine, all nice and good. But the one I want to focus on here specifically is going to be letter C. Letter C is going to be the kind of the bigger one. It says, what fraction of children buy food from a convenience store or a street vendor? All right. So they buy it from a convenience store or a street vendor. So we have 1/10 here. Okay, so the convenience store or a street vendor. Wow, that's pretty small. Okay, and then what number of children buy food from a convenience store or a street vendor? We want to kind of focus on that, so we take 1/10 times 2,500, and we get, what do we get here? 250. So just pointing out here a couple of important things is that just be sure to read the graph carefully and just record your results, and you can still set up the, again, you still see of here, what number of, right? What fraction of, all right? Something to that effect. Okay. Questions about that? That's pretty much the end of section 2.6. Now we have about 10 minutes left, and I do want to do a small portion here to give you a good idea for section 2.7. So let's talk about doing section 2.7 and dividing some fractions. All right. Okay. The first thing we need to do is, of course, talk about the rule when it comes to dividing fractions. So let's talk about that here, because we're going to use this quote-unquote rule here quite often for division of fractions. And sometimes it may seem a little confusing, but once we start putting it together, it'll gradually get easier. So what exactly is the rule here? Well, as we took a look at the rule for multiplication, it pretty much works, no, maybe not exactly the same way. Not exactly. Let's put our letters here, though, a over b, and we'll put that divided by c over d. Now the problem is with division, you cannot divide straight across, all right? You can't do like a divided by c and b divided by d. That's really hard to do when you have, say, two different sets of numbers. If you had like 1/2 divided by 3/4, you'd be like, it's kind of hard to divide 2 and 4, a little awkward there. 1 divided by 3 is very awkward if you go like that. So basically at the end of the day is we want to put it into context we do understand. And so the trick is for us to change it to a multiplication problem. Okay, so we're going to have, in this case here, we're going to rewrite this as a over b, but we're going to change it to multiplication, but of course not without a consequence. So the consequence is that the second fraction here, the c over d, will flip over. So we'll have d over c instead. Okay. So this is the rule that we have here for our guys. Okay. So basically, we change. We change from division to multiplication and flip the second fraction. All right. Now this flip here does have a name, and you can see it right on the screen. So the flip is called the reciprocal. So I can't spell. P-R-O-C-A. All right. So the flip is called the reciprocal. All right, meaning you just flip that fraction over, just like so. Okay. So let's take a look at some problems here, and let's see what how we can go ahead and figure out how we can divide fractions. All right, I'm just going to make up a couple of these here. We'll talk about the reciprocal as well. Okay, so let's do this out here. Okay, so let's do 2/5 divided by 1/4. Okay, so if we go ahead and do this out, and we want to say, okay, well, how do we divide these two fractions? All right, so let's use the rule that we have. We can see here, we're going to go ahead and rewrite it as a multiplication problem. So we'll have 2/5 times, and then we're going to flip 1/4 around. So we're going to have 4, let me put that as a different color. Sure. We're going to have 4 over 1. Okay, so this is the reciprocal here of 1/4 is 4 over 1, just flipping it around. And then all we have to do after that is just multiply, just doing the same things we did in the last couple sections, reducing it down if it's necessary. In this case, there's nothing in common between the numerator and denominator. So in this case, we multiply straight across and we get 8 over 5. All right. Let's go ahead and try another one. All right, let's try 5/9 divided by 10 over 21. Okay, so 5/9 divided by 10 over 21. So can anybody tell me here, how can I rewrite this problem? What is that? What can I rewrite that to? 5/9 divided by 10 over 21. Anybody tell me how that would be rewritten? I'll wait. It's fine. 5/9 times 21 over 10. Okay. Okay. Well, we haven't reached that stage yet, Hannah. You have to first go ahead and change it from division to multiplication. Then once you change it to multiplication, then you can go ahead and reduce stuff down as necessary. If you did so. So in this case here, 5 and 10 do indeed go together. I will agree with that. So we'll divide by 5 here. So we get 1 and we get 2. 21 and 9, do they have anything in common? 21 doesn't go into 2, obviously, but how about 21 and 9? 3. I agree. Good. So this is 3, and this is 7. So we get 1 times 7 over 3 times 2. So the answer here is going to be 7/6. Okay. And that's our final answer for that problem. So we got a little bit of a preview here for division of fractions, and at least to how it works, how dividing of fractions work. It's not too bad. We're going to look at a few more examples here for next time, as we're out of time here for today. Certainly a few more things to look at. We'll do some applications with division, which can be a little tricky at times. And then we'll get to mixed numbers, and then after that we're going to do the toughest part here. After that we're going to get into chapter 3 after all that stuff, and yeah, you're gonna. What did I divide the 21 by? Oh, I'm sorry. You're right. Let me go back. I divided the 21 by 3. Sorry. So 21 divided by 3, and the 9 divided by 3 here to get 21 divided by 3 to get the 7, and then the 9 divided by 3 to get the 3 here. Sorry if I wasn't clear about that when I wrote it down. So no problem. I'm here to help. Homework? Homework is, so if we're going to keep track here, we're going to go up to, we got to still do that stuff. That's a lot to do, but that's part of the deal. Up to 2.7. All right, so up to 2.7, so 2.5, 6, and 7 is what we have here. We're going to transition in section 2.8 is the last section in chapter 2, and we're going to transition right into chapter 3. So yeah, chapter 2 and 3 will go together. So no problem. All right. Any more questions? Okay. Nope. All right. If there are no more questions, we're going to end off here for today. Thank you all very much for coming out to the stream here once again. All right. I really appreciate it. I wish you all a very wonderful weekend. All right. And make sure to finish the homework and the test for chapter 1 by the end of this week on Sunday. All right. Okay. All right, so take care, everybody. We'll see you later. If you're here for my 11 o'clock class, I will be back on in 10 minutes. All right. Have a great one, everyone. Everybody, take care of yourself, and we'll see you later. All right.